Good day. So for this particular video, let's continue to learn about the number system conversion, and let's proceed with the learning on how to convert any number to octal form. So let's start with binary to octal. So to convert binary to octal, you need to convert or to break the binary number into 3-bit sections, and that would be from right to left. So that means if there is any grouping that does not reach 3 digit, you just have to add 2 zeros to the left of that particular section. Now, so after you convert or after you group them into 3, you convert them into its octal equivalent. So for example, let's start with the problem 1111110110010. So to convert this to octal, okay, this is in binary form, so we group them into 3 digits starting from the left side. So we have here 010, so we break that one from the right, and then we have 110, and then there will be another section with 110, and the last and final section will be the 3 zeros. Now there are no other remainders to the left of this problem, but if there's any, as I mentioned earlier, you just add 2 zeros. Now, so once you have broken them down into 3 digits, we convert them back to its octal form using the conversion that we have discussed in the other video, which is 4 to 1. So if it is 0, 1, 0, so you only have activated the 2 part for 4 to 1, so that's 2. Now 4 to 1 for 1, 1, 0, that means 4 plus 2 plus 0, so that would be 6. And then we have 110 again, so that will be again equivalent to 6. And 4 plus 2 plus 1 is equivalent to 7. So just remember the placement 4 to 1 for the 3 digit here, and you'll be able to come up with its octal equivalent. So in other words, your binary 111110110010 in binary may be converted into 7662 in octal. Now let's have another example, and this time if you're going to group this binary number by 3 starting from the right, you have 1 digit remaining, and as mentioned before, you only need to add 2 zeros to the left of that number. So if you partition this starting from the rightmost, 1, 2, 3, that's one group, 1, 2, 3, that's another group. You count another 1, 2, 3, that's 110, that's another group. You have 111, that's another group. You have 010, and of course you have the remaining one, wherein, as mentioned, you only have to add 2 more zeros to its left. So given that sectioning, you just simply have to again go back to 4 to 1, and so this is 2, this is 4 plus 2 is 6, again 4 plus 2 is 6, 4 plus 2 plus 1 is 7, 2 is of course 2, and then you have 1 is equivalent to 1. So your binary 10101111110010 is equivalent to 127662 in octal form. Okay, now let's move on to converting or learning how to convert binary numbers to its octal conversion or octal form. So for the whole numbers, you simply need to convert it by dividing it continuously by 8, and if it is a decimal part, you just need to multiply it by 8. So this is going to be familiar with you because we did the same thing for our binary conversion in another video. So 87 in binary, or rather in decimal, to convert that to octal, you simply need to divide 87 divided by 8. You get 8, and your remainder is 7. Okay, remember that when you multiply 10 plus 8, multiply 10 and 8, you get 80, you have a remainder of 7. So that's one way to check. So your quotient is 10, your remainder is 7. So set aside the remainder, focus on the quotient. So 10 divided by 8, that would be 1 with a remainder of 2. And then continue dividing 1 by 8 until you get 0. So you now have 1 divided by 8 is 0 with a remainder of 1. So disregard 0, you read it from the bottom up. So you don't read it as 7 to 1, but rather 1 to 7. So your equivalent decimal, 87 in decimal, is equivalent to 127 in octal. Let's have another conversion, and this time it's in decimal form. So if it is 0.711 in decimal and convert it to octal, you simply need to multiply it by 8. So, and then again, just like what we did in another video, you separate the whole number from the decimal part and continue multiplying by 8 until you reach the number of digits that are asked from you. So if your teacher says you have to give 5 digits or 3 digits or 8 digits of or 8 positions or decimal places, then you have to multiply the numbers that number of times as well. So starting from 0.711, so 0.711 times 8, you take out the whole number. So that would be 5.688. You take out the whole number, which is 5. You continue multiplying the decimal part, which is 0.688 by 8. And that will give you 5.504. Again, set aside your whole number 5 and continue multiplying 0.504 by 8. And then, so 0.504 times 8 is 4.032. Again, set aside 4. And continue multiplying 0.032 by 8 if you need one more digit, and so on and so forth. So, again, if your faculty or your teacher in charge asks you to submit up to 4 decimal places, then that would mean you'll have to multiply 0.032 one more time by 8. And read it from top to bottom, not bottom up. Okay, so top to bottom, that would be 554. So the equivalent of 0.711 in decimal to octal is 554. Okay, let's continue. Now, so the next one is learning how to convert hexadecimal to octal. So to convert hexadecimal to octal, you first have to convert it either to decimal and then decimal to octal, or convert hexadecimal to binary and then binary to octal. So it's really up to you. So for this video, I will only discuss how to convert hexadecimal to decimal and then decimal to octal. But note that if the instruction in the exam says otherwise, like for example, you are asked to convert from hexadecimal to octal through binary, that means to say that you convert first your hexadecimal to binary and then binary to octal. And of course, the answer is still going to be the same, assuming that you got everything right. But for this example, I will be converting this original hexadecimal number to decimal first, and then decimal to octal. So to convert hexadecimal to octal, as what you have learned in the other video, you multiply each number by 16 raised to the power of the position of that particular number. So for example, for the first one here, the first digit, which is 1, so that would be 1 times 16, again 16 because this is in hexadecimal form to be converted to decimal, times, I'll raise to the power of 1, which is the position, the relative position of that particular number from the right. So from the right, that would be position 0 and then position 1. So that explains why this is 16 raised to the power of 1. And then the next number, which is also coincidentally 1, is going to be multiplied by 16 raised to the power of 0. Again, why 0? Because this is the position, or the placement is on the first position, which is considered as position 0. Alright, so 1 times 16 to the power of 0, and you will get 17. Alright, so 17 is now your hexadecimal 11 converted to decimal. So from this decimal form, which is 17, we convert this one to octal. And how do we do that? We simply divide it by 8. So 17 divided by 8, you have 2 with a remainder of 1. You set that aside. And then you have 2 divided by 8, you have 0, remainder 2. So now we end because we have now reached 0 as the whole number. And that's where we end. And we read it from bottom up. So from 17, which is in decimal form, the equivalent to that in octal is 21. So in other words, from 11 in hexadecimal form, the equivalent to that in octal is 21. So again, guys, this is hexadecimal to decimal, decimal to octal. There is no direct conversion from hexadecimal to octal. So we simply either need to go through decimal or to go through binary. Alright, so just review the video on how to convert hexadecimal to binary and binary to octal if you need to use the other option. Okay, so for this video, we learned how to convert binary to octal, and that is simply by grouping it by 3 and remembering the placement of 4, 2, 1. And then the other lesson that we have learned for this video is we learned to convert binary to octal, which means dividing it continuously by 8 if it is a whole number, and multiplying it continuously by 8 if it is a decimal number. So for whole numbers, when we divide it by 8, we read it from bottom up. If it is the decimal part and we multiply it by 8, we read it from top to bottom and base it on the number of digits that is required from you by your faculty. Now the last but not the least lesson for this video is how to convert hexadecimal to octal. And I also mentioned that you have two ways here because there is no direct conversion from hexadecimal to octal. Either you convert your hexadecimal to decimal first and then to octal, or you convert your hexadecimal to binary first and then binary to octal. Okay, with this, thank you very much, and I hope that you learned how to do it very clearly. If you have any questions, please raise them in the open forum.